Have you ever considered the possibility that spacetime, as we know it, might not bend at all, as suggested by Einstein's theory of relativity? What if the very nature of spacetime is drastically different from what we've come to accept? This is where the theory of modulated oscillation architecture, or TMOA, comes into play. A theory that pivots on the idea that instead of spacetime bending, it's the objects within a particular area that experience a slowdown, while time itself continues to flow in the same manner. Imagine an object moving from point A to point B. Under normal conditions, it takes a certain amount of time. However, in other conditions it might take more time. Or perhaps under some circumstances it may even take less. Consider a person moving at a certain speed on land, then transitioning to water. Their speed decreases. Now take that person deeper underwater, say 40 meters. The pressure increases and their speed decreases further. This is an example of how different conditions can affect the speed of an object, similar to the concept proposed by TMOA. In contrast to General Relativity, which proposes that mass-energy curves spacetime, TMOA offers a different perspective. Instead of spacetime itself bending, TMOA suggests that the underlying reality parametrically modulates probabilistic wavefunctions throughout derivations. In areas of increased density, such as mass concentrations, these probabilistic streams experience a relative slowdown compared to less dense domains. The objects themselves don't necessarily accelerate or decelerate absolutely, but experience relativistic effects relative to potentialities in their localized region. This provides an explanation for the time dilation observed near massive bodies, without the need for a curvature of geometricized spacetime. TMOA sees relativity as emerging from deeper coordinative architectures intrinsic to possibility itself, as opposed to being fundamental properties of some dimensions. In essence, TMOA proposes that relativistic behaviors don't demand a bending spacetime. Instead, they arise from coordinative architectures that parametrically configure probabilistic wavefunctions within localized probability densities. This can be due to mass, pressure gradients, or other factors that amplify implicate activations in a given region. The realm of possibilities itself may therefore exhibit scale-invariant relativistic signatures without the need for geometricized containers. This perspective sets TMOA apart from traditional theories, and it's an idea that merits further reflection. Does this make you question the nature of spacetime as we know it? Do you find this perspective on TMOA enlightening? It's always exciting to explore new theories and ideas, especially when they challenge our understanding of the universe and its workings. Remember, in the realm of science, nothing is ever truly set in stone.